Okay, looking at the do now, we have our first problem. We have an item that is on sale, so we're talking about some sort of discount. I'm going to go ahead and draw my diagram here, a visualization of this. It's $0. It normally costs $64, so the full price is normally $64. It is on sale for 1/4 of the original price. Sorry, that should say 1/4 off the original price. So we're looking at this, and if we're taking 1/4 off the original price, this is our 1/4 that we're taking off. That leaves us with 3/4 of the original price. So 3/4 of the original $64 is going to give me $48. That's choice B. Looking over here, the next one, we have a markup. So that means our diagram is going to involve two parts. We have the original $0 to $5. And we have an additional 1/4 of $5 added on. So we've got these 4/4 I'm still paying, but I'm also paying an additional 1/4. So that gives me a total of 5/4 of $5 is equal to 25 over 4, which is equal to 6.25. Alright, let's flip on over and look at our classwork for today. Today's aim, same as yesterday's aim, Kipsters will be able to solve consumer math problems. Felt like we just needed a little bit more practice on this. In fact, we're not even going to go through solving them. I think it's the setting up that's really hurting us. So today we're just going to look at a bunch of problems. During our lesson, we're going to be able to compare and contrast the two different problems. Solve consumer math problems. Alright, so looking at this, a store discounts a pair of shoes for 2/5 off. The original cost was $60. And what was the discounted price? If the original price, comma. Alright, so looking at this, we want to see that this is definitely a discount. So I want to think about how I'm going to go ahead and set this up. So do me a favor, go ahead and draw the visual diagram for this. Alright, so hopefully what you've looked at is you've drawn a diagram. The original cost, the total piece would be $60. And you've broken this down into 1, 2, 3, 4, 5 pieces. These 2/5 are the 2/5 that are taken off, which means what I'm left with is the 3/5 of the $60. So that's what I'm going to end up paying. What is the discount price? Alright, the discounted price is 3/5 of the original price. And that's as far as I want to go. I'm not really worried about solving it. If you really want to solve that one, this one's going to be $36. Alright, a store discounts a pair of shoes for 2/5 off. The discounted price is $60. What is the original price? So let's look at the difference between these two problems. These two problems look exactly the same, but they're not exactly the same. They both start with a store discounts a pair of shoes for 2/5 off. But what is the real difference here? Hopefully you notice that this one is asking us for the original price, whereas this one asked us for the discounted price. This one also gives us the original cost, where this one gives us the discounted price. So when we think about how we set that up, our setup's going to be a little bit different here. This tells us that we don't know the original price. We don't know what the whole thing was before there was some sort of discount. Now the rest of it's going to set up the same. I still took 2/5 off whatever this price was and was remaining with 3/5 of it. The difference is I don't know what this original price was, what that whole thing was. So I took 3/5 of something that I did not know, and what I got was the price of $60. So we can go ahead and solve this if we wanted to. I'm not going to spend a lot of time doing it or asking you to do it, but we divide both sides by 3/5, and what we end up getting is that x is equal to $100. So again, noticing the small difference there makes a big difference in how we set it up. We're going to recognize that whenever we're given the discounted price and not the original, we're always going to end up needing to solve an equation. Whereas if we are always looking for the discounted price and we're given the original, we're always going to end up just having a multiplication and no equations to set up. Let's look at two more examples. What is the cost of a $2,200 scooter after it's discounted of 1/5 of the original price? Alright, so looking at this one, the wording's just a little bit different here, but we want to think about how to set this one up. Go ahead and try and set up the diagram for this one. Okay, hopefully your diagram looks like this. We know that we're breaking it up into fifths. It's a discount problem. 0, 2. Alright, the scooter is $2,200, and we want to know what it is after the discount. So what we're looking for here is our unknown value of what it is after the discount. So we know that the scooter originally cost, it's a $2,200 scooter, but we're getting 1/5 off. So what we're left with is our unknown here is 4/5 of that original cost. So 4/5 of $2,200. So again, looking at the language there, we want to make sure that we have the language here correct, and that way we know that this is the original price. It tells us that it is a $2,200 scooter, and we want to know the cost after the discount on the original price. Okay? So looking at the next one, the next one says, what is the original price? That should ring some bells in our head that we are not given the original price. So go ahead and set this one up visually. So hopefully what you've set up here is you're recognizing we didn't know the original price, so we didn't know what that is. We're looking for a discount of 1/5. So this is going to look exactly the same as the previous one. We have 1/5 off. We know that we paid $220 after that 1/5 was taken off. And that $2,200 was representative of 4/5 of the original price. And so we have this equation to solve. And again, I don't want to spend a lot of time solving the equation. I'm more worried about getting it set up. So again, notice the difference between these two problems. Very, very similar. One of them is asking us for the original price, and one of those is asking us for the cost after the discount. So we can summarize here looking at the discount problems just by making sure that we recognize when we are asked for the original price that we end up solving an equation, as we did in these two problems. Both of them ask for the original price. And these two problems, when we are given the original price, it ends up just being our multiplication. Alright, moving on to some markup problems. A motorcycle dealer pays $1,200 for a motorcycle. So thinking chronologically, if they pay $12,000 for the motorcycle and then they mark it up, our original amount here is $1,200. So, or $12,000. And we're breaking it into fifths, but what we know here is that this is going to be an increased price. So they're actually increasing the price. They're adding to this price. So this is my whole, but I'm adding an extra fifth to that. So when I think about this, I have 5/5 of the price that I'm going to have to pay, and then they add an additional fifth to that price. Okay, how much will he sell it for? We're given the original is $1,200 or $12,000, and we want to know how much he sells it for. So what we can see looking at this diagram is we have one whole plus 1/5. I'm going to write that as the improper fraction. 6/5 of the original price, $12,000, is what I'm going to have to pay. Again, we could worry about solving this particular problem. I'm not worried about that. I know you can do the math. So looking at this next problem, we have a motorcycle dealer that paid a certain price. And so I'm immediately looking at this and saying, he paid a certain price. That's chronologically the first thing that happened. And then he marks it up. So the original price here is what our unknown is, because we know what he sold it for. So this ends up being, we know he sold it for $14,000. So when I set up my diagram, I don't know what this original price was. I know that whatever the original price was, I paid that original price, plus I paid an additional 1/5 of that original price. So in total, I paid 6/5 of that original price. So I end up saying 6/5 of that original price that I don't know was equal to the $14,000 that I paid for this. And so we have this equation to solve. Again, we can compare and contrast these two problems. One of them asks me how much he will sell it for, and so that's going to be what our marked up price is. And one of them asks us for our original price. And that's going to be a big signifying difference for us. Again, we recognize when we're not given the original price, that's when we get our x over here. We don't know what we multiplied our fraction by in order to get what we have here. So if you're looking to identify, always be identifying whether you're given the original price of an item or not. Let's look at two more examples. In a store, an item costs $172. If the item was marked up 1/2 before it was placed on the sales floor, what was the price that the store paid for the item? So again, we're looking at this. This is an item where we paid something for it, and now we're selling it for $172. So I should be thinking to myself, what is the original price? Go ahead and set up your diagram for this particular problem. So looking at our diagram, we should be thinking about this as it's a markup, so we know that there was something added to it. And I want to know what the price was the store paid for it. This was the original price. I don't know what it was. So I know this is one where I'm going to need an equation. And I know that once I mark it up, the price was $172. So now that I draw my diagram, I'm going to pay 1 whole plus they marked it up 1/2. That means that I have a total of 3/2 of the original price. Again, I don't know what that original price is, but 3/2 of the original price is equal to $172. Again, we could go through and solve this. I'm not worried about solving it at this point. I know you know how to do that. I want to worry about setting it up. Looking at the next one, it says a store purchased an item for $172. Then the item is marked up 1/2 before being placed on the sales floor. What does the price be on the sales floor? So when we think about markups, once again, chronologically, the first thing that happens, the original price is whatever the store purchases it for originally, and then the final price is whatever they sell it for, the marked up price. So again, go ahead and set up the diagram for this one. We'll see if we get it set up right. So looking at this, we should set this up. We know what the original price was. Originally it was $172. That was 1 whole. We know that they added on to that 1 whole by increasing it by 1/2. So I have 2/2 or 1 whole from the first one, and then I add an additional 1/2. So both of these are of 72, so I have 3/2 of 72, or 172, excuse me, and that's going to tell us what our actual price is on the sales floor. Okay, so again, recognizing the difference between these two problems. One of them, it gives me how much the item costs in the store, but not what they originally paid for it. So this one asks for what the original payment was. And this one, we're being told what they paid for it, what that original amount was. So again, that makes the big difference in our diagram between knowing what the original is and not knowing what the original is. So when we look back again, something that we noticed with the markups, it's the same thing as before. We had these two problems where we don't know how much they originally paid for it, and those two problems we end up with our equations. Also, we can notice the difference between the markups and the discounts, thinking about what they look like in terms of their diagrams. When there's a markup, you notice that we always have 2 parts at the very least. There could be 3 or 4 if they mark it up by more than 1 whole. And on the discount problems, we just have the 1 because we're taking 1 whole and we're breaking it down, not adding to it. So, just to summarize this lesson, we should be thinking about these diagrams, and the diagrams really come from the words. If we're not given the original amount of an item, then we're going to have to solve an equation. If we are given the original amount, then it ends up just being a multiplication. I'm going to very quickly jump through these problems and just worry about the setup. Again, we weren't really worried about solving them. I know you know how to solve them. We're just going to focus here on getting these set up. So make sure that you have all of these set up. If you don't, go ahead and pause the video right now and get all of these problems set up, or you can set them up one at a time and then check in with the video. Alright, so a new pair of Jordans is on sale for 3/5 off. The discounted price is $72. What was the original price? So again, I see this is one of those asking me what the original price was. It's a discount, so I'm only going to need 1 bar here. I don't know what the original price is, so I've got an X over here. It's telling me it's 3/5 off, so 3/5 off. That leaves me with 2/5 of the original price is $72. So 2/5 of the original price is equal to $72. $72. A store marks up an item to $125. So again, this is what the changed value is. I want to know, being asked in this problem, what they purchased the item for. So once again, this is a problem where I don't know what that original amount is. That means I know that I'm going to have to do an equation for this. I also see that it's a markup, so I know that I'm going to need at least another bar. They increased the cost by 3/4, so they took 3/4 to add on. So there was already 4/4. That's a total of 7/4 of this original price that I don't know is the $125 that I'm going to end up paying. Basketball is on sale for 1/3 off the original price of $36. So we're given here the original price of $36. So when I set this one up, it's a sale, so it's a discount, so I only need the 1. Break it down into thirds. This is the 1/3 that I'm getting off. That means I have 2/3 remaining. And this was, the original price was $36. So 2/3 of the original price, which in this case is $36, is going to be how much I end up paying. A used car dealership buys a car for $5,000 and then marks up the price 3/10 to sell the car. What will the dealership sell the car for? So this is, I'm looking for the after. I'm given the original cost of the car. It was $5,000. And then they added on to an additional 3/10. 1, 2, 3, 4, 5, 6, 7, 8. They marked up the price an additional 3/10. 1, 2, 3. And that's in addition to the 1, 2, 3, 4, 5, 6, 7, 8, 9. The 1 whole that I already had. So I have 10/10 plus 3/10. That's going to give me 13/10 of the original price. It's going to be how much I will end up paying for the car. So again, recognizing this one, $5,000 is what they originally paid for it, the original price. Car dealer paid a certain price for a car and marked it up by 2/3. So again, a markup. So I'm going to have the whole plus some amount added on. That amount added on is 2/3. As I'm drawing my diagram, I'm being told what they sold it for, not what they originally paid for it. So I have an X for this. When I look at my breakdown here, I see that I have a total of 1, 2, 3, 4, 5/3 of whatever that original price was equal to the $24,000 that we marked it up to. A discounted pair of shoes costs $64. If the shoes have been discounted 1/5, what was the original price of the shoes? What was the original price? So again, drawing my diagram. It's an unknown original price. It's been broken up into 5 parts. This 1/5 is what is being sold, or what's being taken off, leaving me with 4/5 of the original price. 4/5 of the original price, which I don't know, is the $64. The discounted price of the pair of shoes is $64. So we end up with this equation to solve. Corner store purchases a bottle of Gatorade for 60 cents. So that's how much it originally cost, and marks it up 5/4. What is the cost of the Gatorade on the shelf? So here we have 0.6 and we're adding on to that. Now this one's a little bit odd because we're not just adding on one whole. This is more than one whole, so it's actually additionally I have to add more. So here's the original 4/4 plus 1, 2, 3, 4, and I need another 1/4. So this is 4/4 and 1/4. So those are the 5/4 that we added on. That gives us a total of 9/4 of the original price. We do know the original price, so it's 0.6 times 0.6 is going to be the value of that. Alright, last one. A DVD normally costs $15 and is on sale for 1/6 off. What is the sales price? So again, we're looking for the sales price. That means we're given the original cost is $15. Break this down in 1, 2, 3, 4, 5, 6 parts. 1/6 is coming off, leaving me with 5/6 of the original price. So 5/6 of the original price of 15 is going to be the value we are looking for. Alright, so that should be everything all set up. Please make sure that as you're going through this, you're always identifying whether you have the original cost or not. That makes the big difference here.